Binomial expansion of ax plus by to the power n, finding the largest coefficient. If we look at the coefficients for x plus y to the power 4, we see that they increase from 1 to 6 and then decrease from 6 to 1. The coefficients for x plus y to the 5 increase from 1 to 10, remain at 10 for one term, and then decrease from 10 to 1. The coefficients of 2x plus 5y to the power 6 increase from 64 to 37,500, remain at 37,500 for one term, and then decrease to 15,625. For x plus y to the power 4, the coefficients do not start to decrease until we have passed the third term. For x plus y to the 5, the coefficients do not start to decrease till we have passed the fourth term. For 2x plus 5y to the 6, we have to pass the sixth term before the coefficients start to decrease. However, it's not at all obvious what will be the largest coefficient in any of these expansions, nor where it will occur. What we need is a method that allows us to determine both of those facts for the arbitrary expansion of ax plus by to the power n without performing the whole expansion. We need a formula. And that formula should allow us to calculate the index of the term containing the largest coefficient. We usually call that r, in terms of the values of a, b, and n. And the expansion of 4x plus 1/5 y to the power 5 should show us that this is a slightly subtle question, because in this case, the coefficients decrease from 1024 to 1 over 3125, and the largest term is in fact the first. There is no pattern of increasing terms in this particular expansion. Let's look at the expansion of 2x plus 5y to the power 6, which I've shown here. The numbers in front of each term, like 64, 960 and so on, are called the coefficients, and I've named them c sub 0 to c sub 6. The general coefficient is called c sub r, where r ranges from 0 to 6. I've made a list of the coefficients here, and we're interested in finding the largest coefficient. We can see that the first coefficient, 64, is less than 960. 960 is less than 6,000. 6,000 is less than 20,000. 20,000 is less than 37,500. 37,500 is equal to 37,500. And 37,500 is greater than 15,625. In terms of the names of the coefficients, c sub 0 is less than c sub 1, c sub 1 is less than c sub 2, c sub 2 less than c sub 3, c sub 3 less than c sub 4, c sub 4 equal to c sub 5, c sub 5 greater than c sub 6. So here we have a sequence of increasing coefficients. The coefficients increase from C0 to C4, and that tells us that C4 is the largest coefficient. Its value is 37,500. We need a process that tells us when that sequence of coefficients stops increasing, since the largest coefficient will occur at the end of a run of increasing coefficients. So we have 6 facts. C sub 0 is less than C sub 1, C sub 1 is less than C sub 2, C sub 2 is less than C sub 3, C sub 3 is less than C sub 4, C sub 4 equals C sub 5, C sub 5 is greater than C sub 6. And we can summarize those facts by saying if C sub r minus 1 is less than C sub r, then r is less than 5. Now, this if-then statement tells us what we have to do. We need to take this expression, c sub r minus 1 is less than c sub r, express it algebraically, and show that the fact r is less than 5 follows from that statement. Or to put it another way, we have to show that c sub r minus 1 is less than c sub r implies r is less than 5. Now, of course, in this case, we already know in advance that r must be less than 5 by looking at the sequence of coefficients in the expansion of 2x plus 5y to the 6. However, in general, what we need to do is take the expression c sub r minus 1 is less than c sub r and derive an unknown condition on r. Because, of course, we want to be able to find the largest coefficient without performing the full binomial expansion. So we want to find the largest coefficient in the expansion of 2x plus 5y to the power 6. What we will do is show that c sub r minus 1 being less than c sub r tells us that r must be less than 5. Then to find the largest coefficient, there are two steps. Firstly, we find the largest value of r, which we will call r max, that satisfies the following three conditions. R is less than 5, which we will have shown here. R lies between 1 and 6, and R is an integer. Those three conditions must be satisfied simultaneously. Now, why must R lie between 1 and 6 inclusive? Well, if we look at our expression c sub r minus 1 less than c sub r, we see that if r was 0, then r minus 1 would be minus 1, and there is no c sub minus 1 coefficient. It simply doesn't exist. So we must restrict r to be between 1 and 6 inclusive to ensure that c sub r minus 1 is a meaningful value. If we were to allow r to be 0, then the expression c sub r minus 1 would produce c sub minus 1 is less than c sub 0, which is completely meaningless. And secondly, we calculate the largest coefficient by substituting r max, which we have just found, into the formula for c sub r for this expansion. The general term in the expansion of 2x plus 5y to the 6, which we will call t sub r, is 6 choose r 2x to the 6 minus r times 5y to the r, which splits up as follows: 6 choose r times 2 to the 6 minus r times 5 to the r, which is the numeric part, and x to the 6 minus r times y to the r, which is the algebraic part. The numeric part is what we call the coefficient, and the general coefficient is c sub r, which in this case is 6 choose r 2 to the 6 minus r times 5 to the r, which we can simplify to 6 choose r times 2 to the 6 times 5 to the r over 2 to the r. Now, we are interested in the condition c sub r minus 1 is less than c sub r, which is equivalent to 6 choose r minus 1 times 2 to the 6 times 5 to the r minus 1 over 2 to the r minus 1 is less than 6 choose r times 2 to the 6 times 5 to the r over 2 to the r, using this expression for c sub r. However, recall that this inequality is subject to the conditions r lies between 1 and 6 inclusive, and that r be an integer. And now we have to simplify this expression to find out what it tells us about r. In the first step, we rewrite 5 to the r minus 1 as 5 to the r over 5, and 2 to the r minus 1 as 2 to the r over 2. We then use the invert and multiply rule to rewrite this fraction as 2 times 5 to the r over 5 times 2 to the r. And now we can cancel the 5 to the r here on the left-hand side of the inequality with the 5 to the r here on the right-hand side, and similarly for the 2 to the r here and the 2 to the r here. And our expression reduces to 6 choose r minus 1 times 2 over 5 is less than 6 choose r. Now we have to deal with the 6 choose r minus 1 and the 6 choose r terms. We start with 2 times 6 choose r minus 1 is less than 5 times 6 choose r, which we get from this expression by multiplying both sides by 5, and we rewrite 6 choose r minus 1 as 6 factorial over r minus 1 factorial times 6 minus r minus 1 all factorial, and we replace 6 choose r with 6 factorial over r factorial times 6 minus r factorial. And by cross-multiplying by r factorial and 6 minus r minus 1 all factorial, we obtain 2 times r factorial over r minus 1 factorial is less than 5 times 6 minus r minus 1 all factorial over 6 minus r factorial. Now, to simplify these factorial expressions, we need two identities. The first is r factorial equals r times r minus 1 factorial. The second, which is slightly trickier, is 6 minus r minus 1 all factorial equals 6 minus r minus 1 times 6 minus r factorial, which we get to by replacing 6 minus r minus 1 with 6 minus r plus 1, and we can then factorize that into 6 minus r plus 1 times 6 minus r factorial, which follows by analogy with that result. And applying those identities, the left-hand side reduces to 2r, the right-hand side reduces to 5 times 6 minus r minus 1, which simplifies to 2r is less than 5 times 7 minus r, which is 2r is less than 35 minus 5r, which becomes 7r is less than 35, which tells us that r is less than 5. And so we have shown that for the expansion of 2x plus 5y to the 6, the expression cr minus 1 is less than cr implies r is less than 5, as we expected, and that is subject to the conditions r lies between 1 and 6 inclusive, and r is an integer. And so now we can find the largest coefficient in the expansion of 2x plus 5y to the 6. We follow the two steps. We find the largest value of r satisfying these conditions. R is less than 5, r lies between 1 and 6 inclusive, and r is an integer. And the largest integer satisfying those conditions is 4, so r max equals 4. And we find the largest coefficient by substituting r max into the formula for c sub r, which is 6 choose r times 2 to the 6 minus r times 5 to the r. So the largest coefficient is c sub 4, which works out to be 6 choose 4 times 2 to the 6 minus 4 times 5 to the 4, which is 6 choose 4 times 2 squared times 5 to the 4, which a calculator shows to be 37,500. And by looking at the expansion of 2x plus 5y to the power 6, we can see that the largest coefficient is indeed 37,500, which is c sub 4. Now, having found the largest coefficient for the expansion of 2x plus 5y to the 6, we want to do it more generally for the expansion of ax plus by to the power n. We need to ask the same question. What does the inequality c sub r minus 1 less than c sub r tell us about r? But in this case, we don't know the answer in advance. Now, we will use the general term for this expansion, t sub r, which is n choose r ax to the n minus r times by to the r. And the general coefficient, c sub r, is n choose r a to the n minus r b to the r, which we can write as n choose r times a to the n times b to the r over a to the r. Now, using the general form of the expression for c sub r, the inequality c sub r minus 1 less than c sub r is equivalent to n choose r minus 1 times an times b to the r minus 1 over a to the r minus 1 is less than n choose r times a to the n times b to the r over a to the r. Now, if we follow a process of algebraic simplification, as we did in the case of 2x plus 5y to the power 6, we end up with showing that r must be less than b times n plus 1 over a plus b. But that, of course, being subject to the conditions r lies between 1 and n inclusive, and r is an integer. Now, in this derivation, I've omitted all of the algebraic details because they're essentially identical to those we went through in the case for 2x plus 5y to the power 6. And of course, if we now take the largest value of r that satisfies those three conditions, it will give us the r max value that allows us to evaluate the largest coefficient in the expansion of ax plus by to the power n. So, having derived these conditions, we can apply them to a few examples. We'll first look at the expansion of x plus y to the power 5, which is shown here. We can see that the largest coefficient is 10, which is c sub 2. In this case, a equals 1, b equals 1, n equals 5. The general coefficient c sub r is 5 choose r, 1 to the 5 minus r, 1 to the r, which reduces to 5 choose r. With those values of a, b, and n, the inequality becomes r is less than 1 times 5 plus 1 over 1 plus 1, which is 6 over 2, which is 3. And so the largest value of r satisfying all three conditions, r max, equals 2. And so the largest coefficient is c sub 2, which is 5 choose 2, which evaluates to 10, as expected. Now let's look at the expansion of 3x plus 5y to the 7, shown here. The largest coefficient is 590,625, which is c sub 4. In this case, a equals 3, b equals 5, n equals 7, and the general coefficient c sub r is 7 choose r times 3 to the 7 minus r times 5 to the r. And so with those values for a, b, and n, the inequality for r becomes r is less than 5 times 7 plus 1 over 3 plus 5, which reduces to 5. And of course, we have the other two conditions, r must be between 1 and 7 inclusive, and r must be an integer. And taking the largest value of r subject to those conditions, we have that r max equals 4. So the largest coefficient will be c sub 4, as expected, which is 7 choose 4 times 3 to the 7 minus 4 times 5 to the 4, which becomes 7 choose 4 times 3 cubed times 5 to the 4, which a calculator shows to be 590,625. And here we have the expansion of 8x plus 9y to the 5, whose largest coefficient is 466,560, which is c sub 3. In this case, a equals 8, b equals 9, n equals 5, and the general coefficient c sub r is 5 choose r times 8 to the 5 minus r times 9 to the r. And the conditions on r now become r is less than 9 times 5 plus 1 over 8 plus 9, which is 54 over 17, which is 3 and 3/17. And of course, r must be between 1 and 5 inclusive, and r must be an integer. And taking the largest value of r satisfying those conditions, we have r max equals 3. And so the largest coefficient will be c sub 3, which is 5 choose 3 times 8 to the 5 minus 3 times 9 to the 3, which is 5 choose 3 times 8 squared times 9 cubed, which is 466,560. The previous three examples have been entirely straightforward, but we'll now look at the expansion of 4x plus 1/5 y to the 5, which will require a little more thought. So in this case, we can see that the largest coefficient is 1024, which is c sub 0, a equals 4, b equals 1/5, n equals 5. The general coefficient, c sub r, is 5 choose r times 4 to the 5 minus r times 1/5 to the r. And with those values of a, b, and n, the inequality for r becomes r is less than 1/5 times 5 plus 1 over 4 plus 1/5, which reduces to 6 over 21. And now we can see that we have a problem, because if r must be less than 6 over 21, which is less than 1, then r cannot lie between 1 and 5. And we see that we have a contradictory set of conditions. There is no value of r that can satisfy these three conditions at the same time. Now, to see why this contradiction has arisen, we can look at the example of 2x plus 5y to the power 6. Here, there is a run of increasing coefficients from c sub 0 to c sub 4. That means that the statement c sub r minus 1 is less than c sub r is true for some value of r which satisfies these conditions. And from the true statement, c sub r minus 1 is less than c sub r, we were able to deduce the true statement r is less than 5. If we look at the expansion for 4x plus 1/5 y to the 5, the situation is different. We now have no run of increasing coefficients. The inequality signs go in this direction, c0 greater than c1, and so on, all the way down to c5. That tells us that this statement, c sub r minus 1 is less than c sub r, is false for any value of r satisfying these conditions. And from the false statement, c sub r minus 1 is less than c sub r, we have derived a false statement, a contradiction. And so in fact, the contradiction, the false statement, is giving us the following useful information. It's telling us that there is no value of r for which we have a run of increasing coefficients. And if we have no run of increasing coefficients, that means that the first coefficient, c sub 0, must be the largest coefficient. And so in the case of 4x plus 1/5 y to the 5, the conditions on r give a contradiction, and that tells us that c0 is the largest coefficient. And finally, we can calculate c sub 0 in the normal way as we've done before by substituting 0 into the formula for c sub r, and that evaluates to be 1024.